All right, everybody. So today we're going to talk about 4-2, solutions of systems of linear equations. So basically you have a system of equations, two equations of lines, and then you're solving that system. Okay, so we're going to go through different examples of what can happen. First example, you might have a system that looks like this. X plus 2y equals 5, and then 2x minus 2y equal to 1. Okay. And when you graph this, what happens? You get one singular solution. Okay. A visual of that looks like you graph a line, you graph another line. Okay. It might look like this. You have one single solution. And that one single solution, one point of intersection, is your solution to this system. Now, we're going to talk down here about 6 different methods for solving systems, but I made this one fairly simple. If you take this first equation and you add the second equation, one of our methods is going to be elimination. So x plus 2x is 3x. The 2y minus 2y, you eliminate the y's, that's going to be one of our methods, equals 6. Okay, so this solution, divide both sides by 3. Your x value is 2, and then you can plug that x value of 2 back in here, and you're going to get as your solution 3 halves, and that would be your one point of intersection. Your solution to the system would be 2 comma 3 halves. Okay, descriptors of this system, this is called an independent system. Okay, the next type of system is a system where you might have something like 5x plus 2y is equal to 10. And then your second line is 5x plus 2y is equal to 20. Okay. Think of what happens here. And in this system, if you were to solve this system, you end up with no solutions. A visual of what that system looks like when you graph those two lines, you're going to get two parallel lines. Okay, no solution because they are parallel lines. And parallel lines never intersect. So there's no point of intersection, thus no solution. Now, real quick, and if this is going to go as fast, don't worry about it. But what happens is, in this one, I've got positive 5x, negative, or positive 2y. I actually can multiply the second equation by negative 1 and then add those together. Okay? You get 0x plus 0y equals, and then you have 10 minus 20, 0 equals negative 10. So what happens is you get a statement that's not true. So no matter what x and y are, this is not going to be true because there's no values of x and y that satisfy both of these equations. This is called an inconsistent system. Inconsistent system. Okay. Finally, you have an equation, something like 15x minus 12y equals 18. And then you could have 10x minus 8y is equal to 12. Okay, and in this case, you end up, what happens when you solve this system? You have infinitely many systems, or infinitely many solutions. And what that looks like, you solve the equation, you graph the first line, and then you graph the second line, and it turns out that those are exactly the same line. So what we can see here is if we take this first equation, let's say we took the first equation and we divided by 3. You can divide both sides of an equation by 3. We'd end up with 5x minus 4y equal to 6. Let's take the second equation and divide by 2. We get 5x minus 4y is equal to 6. Well, what do you know? They're the same line. They just look a little bit different. And these are even both in standard form. So sometimes you've got one in standard form, one in point slope form, or maybe you've got one in slope intercept form, one in standard form, and you can't tell that they're the same line. So you solve the system. And when you solve the system, you're going to get a statement that's always true. You're going to get something like 10 equals 10 or 5 equals 5. So basically all your x's and all your y's get eliminated and you're left with a statement that's true. Unlike here, everything got eliminated and you're left with a statement that's always false because there are no solutions. Here you get something that's always true because there's infinitely many solutions. So as long as a point is on one of these lines, it's also on the other because they're the same line. And this is called a consistent system. So your 3 words: independent when there's one solution, intersecting lines. Oops, I forgot my arrows. That's important to always put your arrows on your lines. Inconsistent system when there's no solutions because they're parallel lines. And then a consistent system, infinitely many solutions because they're the same line. Okay, so let's look at methods for solving a system. Okay, we're going to talk about 6 methods here, roughly 6 methods. So one method is substitution. We'll go through an example of substitution. Another method is called linear combination. Or sometimes it's just called elimination. You might have learned it as linear combination, you might have learned it as elimination, but it's really what we did here. You're eliminating one of the variables, so you can solve for the other variable, and then you plug that back in to find your other ordered pair, your other point, and your other coordinate of your ordered pair. Okay. Third one, graphing. You can solve by graphing. You can graph by hand or on your calculator. We'll go through an example of that. Okay. Number 4 is, let's see, is solving, let's see, graphing on the calculator, solving the system using matrices. Okay, we're going to go through that, but that's going to be in 4-6. We'll learn how to solve by matrices. Okay. And then there's another one, Cramer's rule. Also called second order determinants. This is in 4-3. We are not going to do this method. Okay, if you want to read about it on your own in 4-3, 4-3, okay, we will not do this method, in this class. Okay, you might see that in another class, but it's another way to do it. You can look at it in 4-3. You will not be tested or quizzed on that. Okay, and then finally, there is something called reduced row echelon form. Reduced row echelon form. Reduced row echelon form. Okay, and this is something that's also using matrices. We may or may not get to. Okay, again, this one will not be on a test or quiz. So these 2, I'm going to call them optional because we may or may not get to them. Not on test or quiz. Okay, so we'll focus on the first 4, substitution and linear combination. These 2 are algebra solutions that you've probably seen before. Graphing by hand or on the calculator. You might have seen graphing by hand. We'll show you graphing on the calculator. And then matrices. Okay. Solving by substitution. When do you use this technique? Well, you'll use this technique when it's easy to get one of your variables by itself. Okay. Use this when you can easily isolate one of the variables, the x or the y. Okay? So looking at this, I mean, you can always use substitution. It just isn't always going to be the easiest way. But when you have this x over here, look, we can get that x by itself really easy. So x is equal to, and we'll add the 7y to the other side. So now that's positive 7y minus 22. Now we go to the second equation. This is equal to x. So we're going to plug this in everywhere we see an x. So now we've got 5x. Well, x is 7y minus 22. We've substituted the x with 7y minus 22. And that's why we call it substitution. And now we've got an equation with one variable. Okay, so we can solve an equation with one variable fairly easily. Okay, so 5 times 7y is 35y minus 5 times 22 is 110 plus 2y equals 1. So adding these together, you get 37y equals, add 110 to the other side, 111. Well, 110 happens to be 37 times 3. If you divide both sides by 37, you'll get y equal to 3. Okay, you're not done. You have to solve for x and y. And even when you do that, you're not done. You must give your answer as an ordered pair. Okay, so now we've got the y. We can substitute back into the first or the second equation. I'm actually going to substitute it in right here because x is equal to, we already got the x by itself, 7 times y minus 22. Notice I substituted the y with a 3. So x is equal to 21 minus 22, or negative 1, and your solution to this system is negative 1 comma 3. All right, okay, let's go on to the next page. I'm going to go through some other examples, and we're going to go through these fairly quickly. So feel free to stop and pause or fast forward to one that you have a question on. Okay, so it says for these, you're going to solve by elimination or linear combination. Check your answer using the calculator app, then access solve system of linear equations in the submenu of the algebra menu. Okay, so using, we'll just use the calculator. Okay, so first thing we're going to do, we're going to use elimination. We could very easily eliminate the y's, so I'm going to multiply the first one by negative 1. So now I've got negative 4x minus 2y equals negative 4. Notice if you multiply the first equation by negative 1, you have to multiply everything on both sides by negative 1. Second equation, we're going to leave alone. Now we can add these together. The reason we did that is so that the 2y and the negative 2y cancel. So 6x minus 4x is 2x. 8 minus 4 is 4. So x equals 2. Now I'm going to plug the 2 back into either equation. For x, let's just plug it in here. 6 times 2 plus 2y equals 8. So that's 12 plus 2y equals 8. Subtract 12 from both sides. 2y equals negative 4, and y will equal negative 2. So your solution is 2 comma negative 2. Okay. When we're done with these, I'll show you for one or two of them how to do these on your calculator, okay, to check your answers. This one, okay, we've got 4x and a 6x. We've got a 9y and a negative 5y. Okay, so this is going to be a little bit more complicated, but let's multiply the first equation. The 4x and the 6x, we can get those both to be 12x, one positive 12x and one negative 12x. Let's multiply the first equation by 3 and the second equation by negative 1. Then we've got 12x, negative 2 and negative 12x. So the first equation becomes 12x plus 27y equals negative 18. Second equation, negative 2 times 6x, negative 12x. Negative 2 times negative 5y, so plus 10y equals negative 56. Okay. Add those together, those go away, you get 37y is equal to negative 56, negative 66, negative 74. Conveniently, that's equal to 74 is 2 times 37. We can divide both sides by 37. And we get y equals -2. Plug that -2 into either equation. I'll just plug it into the second equation. 6x minus 5 times y equals 28. 6x plus 10 equals 28. Subtract 10 from both sides. 6x equals 18 and x equals 3. So again, we're going to put our answer into ordered pair, 3 comma -2. Okay, and the next one down here, let's do elimination. This is pretty easy. We'll multiply the first one by 2. So we get -6x plus 10y equals 14. And here we'll get 6x. We're not going to do anything to this one. The 6x's cancel. Minus 10y equals -14. Oh, what do you know? These cancel, we get 0. These cancel, we get 0. These cancel, and we get 0. 0 is equal to 0. We got a statement. Everything eliminated, x's and y's, and we got something that's true. So this solution to this equation is infinitely many solutions. Okay, this is a consistent system. Okay, let's state what these are. These have one solution, so these are both independent solutions. Independent system. Call this one over here independent. Okay, so really the solution is any ordered pair xy, so any xy on either of these lines. So we could say -3x plus 5y equals 7. So any ordered pair xy on this line, because if it's on one, it's on both because they're the same line. It doesn't mean that any x comma y on the xy plane works. It just means there's infinitely many. Okay, let's go to the next one. This one looks like, when I look at this and I have a 10, 15, and a 45, I sometimes will start to simplify. I like to simplify and work with smaller numbers. First equation, I can divide both sides of the equation by 5. Now I'm left with 2x minus 3y equals -9. Second equation, these are all multiples of 6. Not 12, just 6. Okay, so I'm going to divide both sides of the equation, everything by 6's. So -2x plus 3y equals 6. Okay, and look at how convenient that is. The x's cancel. I don't even have to multiply. I don't need a linear combination. I can leave it alone. 2x minus 2x is 0. -3y plus 3y is 0 equals, and add these together, -3. Okay, so all the x's and y's eliminated, and I'm left with something that's not true. So this is no solution. Okay, because we have parallel lines. Basically, we have two lines with the same slope but different y-intercepts. Okay, this is called an inconsistent system. Okay, now let's go to this next one. This one looks tough. This looks different. Okay, but I'm going to show you a way to make this really easy. Okay, so you have 5 over x. This really isn't linear. Okay, this isn't a linear equation. This isn't a linear equation. Linear equation, you can't have a variable in the denominator. It's not even a polynomial. So what we're going to do is we're going to kind of transform it. We're going to transform it so it looks linear. So we're going to let some other variable, I'm going to call it a, is equal to 1 over x. And I'm going to let b equal 1 over y. Okay, so I can rewrite this as 5 times 1 over x plus 4 times 1 over y equals 17. And I can call this -1 times 1 over x plus 10 times 1 over y is equal to 2. 5 over x is the same as 5 times 1 over x. So I just changed the form of those fractions. And now I'm going to replace the 1 over x with an a and the 1 over y with a b. So I've got 5a plus 4b equals 17. And I've got negative 1a plus 10b. 10b, remember b is 1 over y, is equal to 2. And now I'm going to I can use elimination. I can multiply this equation by 5. And then I've got 5a and negative 5a. So 5a plus 4b equals 17. Negative 5a plus 50b is equal to 10. Add these together, the a's go away. I've got 54b is equal to 27. So b is equal to 2. Okay, let's plug b back into one of our equations. I'll plug it into this equation. Remember, you're going to plug it into something that has a b. So before I multiplied by 5. So I've got negative a plus 10b. So times 2 is equal to 2. So I've got negative a is equal to, okay, something's not right. Negative a plus 10b. Oh, here's what I did wrong. I did that too fast. When you divide both sides by 54, b is actually 1/2. Okay, so we have to plug in a 1/2 for b. So we've got negative a plus 10 times 1/2 is equal to 2. So negative a plus 5 equals 2. Add the a over there, subtract the 2. You're going to get a is equal to 3. Okay. A is equal to 3. Yep, that works. But a and b are not what you're solving for. You're solving for x and y. Okay. So if a is equal to 3, you have 3 equals 1 over x. And x is going to be equal to the reciprocal of a, 1/3. And y is going to be equal to the reciprocal of b, which is 2. Okay, so your ordered pair for this is 1/3, comma, 2. Okay, and this would be, we won't even classify it. Okay, if once we transformed it to a linear system, it would be independent. Okay, now let's go to this one. Let's go down to the last one. Okay, did you know you can solve a system by graphing without solving each equation? Actually, let's do this. Let's go to the calculator. I'm going to show you for these how to do these. I'm just going to show you one of them, and I'm going to show you 2 ways to do it. Okay, so actually, if we go back to that previous page, another way on the calculator, if we want to put a number 7 here, you can do solve system on the TI Nspire. Okay, solve system, and I'll show you how to do that. So let's go to one like, let's do A. Let's just go back to the first one. 4x plus 2y equals 4. 6x plus 2y equals 8. I'm going to show you how to do that on your calculator. Okay, so you can go to your calculator. I'm going to go to the home screen. And I'm just going to do new. I don't want to say that. I'm going to just do a new document. Add a graph. Now, you can solve this equation for y, but let me show you something else you can do. You don't have to. You can enter this in standard form by changing your entry mode. Okay, so if you ever forget how to do anything, I always Google it. I go TI Nspire. How do I get standard form in a graph? But you can go to menu and then actions. It's actually our graph entry mode. So if you look at number 3, it's the graph. Oh, that went away. Let's see. 3. If we hit escape, we can get rid of that one. Graph entry edit mode. And we want our equation templates, okay? And then there's equation templates for a line, a parabola, a circle. We just want a line. Now, which one do we want? We want standard form. It also lets you graph a vertical line, which is kind of nice. That's not a function, so the most calculators don't let you do that. Okay, so standard form, put it in standard form. And the nice thing, all you need to do is enter your coefficients. So you can do 4, tab, 2, tab, and 4. The first equation we're looking at, number 1, or letter A, 4x plus 2y equals 4. Hit enter, it graphs that line for you. Go ahead, hit the tab button, and it brings up your second one. We want 6x plus 2y equals 8. So 6, tab, 2, tab, 8, enter. Okay, so there's our graph. What did we get? We got 2, -2 when we solved this algebraically. Okay, now you can go to menu, you can go to geometry, number 8. You can go number 1 for points and lines. You can do intersection points. Remember up here, it tells you what to do if you forget. You want to click on one line, click on the other line, and it gives you that ordered pair 2, -2. Okay. If there were no solutions, what you would see here is 2 parallel lines, and you would see that they don't intersect. And if they were the same line, you'd just see the same line on top of each other. Okay. Now I'm going to show you how to do solve system. So actually, let's just add a page here. So Control Doc, notice behind the doc it says plus page. We're going to add a page, and we're going to just do a calculator page. Okay. So you're going to go to menu. We're going to go to algebra, and then we're going to go to solve. Actually, not solve. We're going to go to solve system of equations. And then solve system of equations, solve system of linear equations. You could do the first one. The second one makes it a little bit easier. Okay, there are 2 equations. That's the default. You can change it if you had 3 equations, and let's say you had 3 variables, but we want 2 equations. We want just x and y, and hit OK. So we're going to write out the equation. So 4x plus 2y equals 4. And that equals, over here left of the 7, equals 4. Okay, tab down here, we've got 6x plus 2y is equal to, what do you get, 8? And we're solving for xy, hit enter, and it actually solved that entire system for us. Okay, now just for fun, I want to go to F. F was messy. So I want to make sure we got that right. It's possible we made a mistake there, but let's do it. Okay, you could go back through the menus. I'll show you menu, algebra, solve system of equations, 2, 2, and we've got that. Okay, or you could have just said, let's say, oh, I don't want to do all those menus again. You can just arrow up, use the arrow up button until if that thing's highlighted, hit enter, it just brings it down. And now we can simply modify. Okay, so either way you want to do it. So this is 0.02 x minus 1.5y is equal to 4. Okay. Now, I know it's A's and B's, but we're just going to use X's and Y's. So 0.5. Oh, let's go back. Okay, if you do something wrong, I think you can do a Control Z and it will undo it for you. You actually can do Control Z, which is nice because sometimes you hit a wrong button and you don't want to redo everything. Okay, so 0.5x minus 0.02y equals 1.8. I double check that I got that right. 0.02x minus 1.5y. I'm doing F on this page equals 4. 0.5x minus 0.02y. Oh, look at what we did. I know what we did. Okay, notice in F, and maybe you already noticed this. This would have made it a lot easier to solve. Okay, they switched the order. This was A and B, and then they did B and A. This needs to be the Y. This needs to be the X. Okay, and let's solve that. And that gives us an answer that's way, way easier. Okay, and this will be way easier to solve. So I know sometimes students make this mistake, but I just got caught in making this mistake. So we get negative 235 and negative 5.8. Let's go back and let's look at that one again. So the first thing, that's a good lesson. So 0.02a minus 1.5b equals 4. Line up the a's and b's. So negative 0.02a plus 0.5b equals 1.8. Those go away. You've got 0.5b minus 1.5b is negative b equals, add those together, 5.8. And what do you know? B equals 5.8. Plugging that back in for b. Let's go to the first equation. 0.02a minus 1.5 times 5.8 is equal to 4. So 0.02a minus, we can use our calculator here, 1.5 times 5.8 gives you minus 8.7 equals 4. So 0.02a equals 4 plus 8.7 is 12.7. 12.7 divided by 0.02. Okay, that's not right. Oh, sorry, that's not, well, that should be 12.7. 0.02a minus 1.5b equals 4. Did you get that right? Oh, this should be negative. Sorry, the b should be negative. So let's plug that in. This becomes a positive. We've got 4 minus 8.7 is negative 4.7. Negative 4.7 divided by 0.02 equals negative 235. So we get negative 235 comma negative 5.8. Let's just double check that's what we got. Yes, they were both negative. Okay. All right. And going back to this page, let's go to the next problem. This equation, and which equation below form a system with no solutions. Okay, what I would probably do is I would find all their slopes. I would put them all into slope-intercept form. Okay, so we've got 3x minus 4y equals 2. Let's subtract 3x from both sides. Divide everything by negative 4. Divide by negative 4 minus 1/2. So your slope is 3/4, your y-intercept is 1/2. The first one, we've got the y by itself. Let's divide everything by 2. Y equals 1/2 divided by 1.5 divided by 2 is 0.75. Divide by 2 minus 1. Okay, this looks like that has the same slope with a different y-intercept. So this one would form a system with no solutions. So we can circle that one. Let's check another one. This one, divide everything by 2. Y equals 0.75x minus 1/2. Okay, that's the same equation. So there will be infinite solutions. Let's go to this one. 4y equals negative 3x plus 2 divided by 4. Y equals negative 3/4 x plus 2/4 1/2. Okay, that will be the same line. Negative 3/4. Oh no, that's not. This one works because they have different y-intercepts, but the same. Oh, they don't have the same slope. Never mind. One has a positive slope, one has a negative slope. Two lines have different slopes. They will intersect, so not that one. Watch your positives and negatives. Let's go to this one. 4y equals 3x minus 2. divide by 4, divide by 4, divide by 4. Y equals 3/4 x minus 1/2. Okay, so that again is the same one. So this one also works. Okay. Oh no, I'm sorry, that doesn't. What did we do? Okay, sorry. We want to find a system with no solutions. And this has infinitely many solutions. So sorry. So just A is the one that's parallel. We're looking for the one with no solutions. These would be identical. Okay. And finally, we're going to solve by graphing. Okay. For these equations, find your x and y intercepts, plot the two graphs on the grid below, then find the point of intersection. If you have difficulty finding the point of intersection, use your Inspire to find the point of intersection, which I just showed you how to do. You may need to change your window to see the intersection point. Okay. So what we're going to do is we're going to find our x and y intercepts. So for the first one, x-intercept is something comma 0. The y-intercept is 0 comma something. So if I plug in a 0 for y, I get x equals -8. I plug in 0 for x, I'm going to get -2y equals -8, or y equals divide by -2, 4. So -8, 0, and 0, 4. Okay, so that's going to be my first line. Let's see if I have a good straight edge. I can use this. Okay. And the second one, something comma 0 and 0 comma something. If we plug in a 0 for y, I've got 5x equals 30. So x would equal 6. When x is 0, I've got -6y equals 30. Divide by -6, y equals -5. So 6 comma 0, and y is -5. Okay, let's draw that line. They look like their slopes are similar, but they don't look like the slopes are the same. We can't see it on this graph. So let's plug these in on the calculator. Okay. Okay, let's go to the graph. Let's just make a new one. File, new document. We don't want to save it. Add graphs. Okay, so we've got x minus, let's change the entry edit mode. So menu, graph entry edit, number 3. Equation templates, number 3. For a line, number 1. And then for a standard form of a line is this one. Okay, so we've got 1x minus 2y equals -8. Oops, -8. 1x minus 2y equals -8. Hit enter. Let's go to the next one. That looks a lot like what we have. 5x. We should put in a -6 minus 6y equals 30. Hit enter. Okay, so we have to change our window. Remember, you can go to menu and you can go to window zoom. I'll show you the other way. You can just double click on this and make that bigger. Maybe we want that to go up to, let's say, 50. I don't know if that's going to be enough, but we'll try it. Hit the tab button, and now we'll make this one go up to, I don't know, 100. Hit enter. Okay, that worked. There's our point of intersection. Okay, this time I'm going to show you a different way to do point of intersection. We'll go to menu, number 6 for analyze graph, intersection. Maybe I showed you this in class. You move this, now it's asking for a lower bound. A lower bound, this is your x value. Notice it's a vertical line, x equals something. So I want your x to be below, hit enter, and then your x to be above, and it gives you that point of intersection, 27, 17.5. Okay, 27, 17.5. which is off the screen, okay? So if I asked you and you needed to show this in this point on your graph, you would need to erase this, make your scales go bigger. Maybe make these go up by 3s and these go up by 3s. So this would be 30. This would be 30. And then we would be able to see 27, 17 would be somewhere over here, be about there, okay? But for now, that's okay. Let's go to the next one. We're going to graph these the same way. Something comma 0 for your x-intercept and 0 comma something for your y-intercept. So when y is 0, we have 2x equals negative 12. So x would be negative 6. When x is 0, I've got 3y equals negative 12. So y would equal negative 4. Negative 6, 0, and 0, negative 4. And the next one, we'll find our two ordered pairs, two intercepts. So when y is 0, I'm going to have 8x equals 40, or x equals 5. When x is 0, I'm going to have negative 5x equals 40, or x equals negative 8. So 5 comma 0, let's first connect these before we do the second one. Okay, put your arrows on there. And the next one, 5 comma 0, and 0, negative 8. Okay, this might be a little harder to see, but let's look at the slope. The slope here was down 4 over 6, negative 2/3, down 2 over 1, 2, 3, down 2 over 1, 2, 3, down 2 over 1, 2, 3. So that should actually be over there. This slope is up 8 over 5. Okay, it doesn't look like that's going to be a real nice spot, so we have to do that one on the calculator. We could do it algebraically. Okay, so we could solve this algebraically. Actually, maybe we'll do this one algebraically. Let's multiply the first equation by negative 4. So we get negative 8x minus 12y equals 48. And then we've got positive 8x minus 5y equals 40. Add those together, negative 17y equals 88. Divide by negative 17, divide by negative 17, so y equals negative 88 over negative 17. Let's see what that is on the calculator. Sorry, negative 88 over 17. There's not two negatives there. 88 divided by 17. So about negative 5.18. Let's see, that's about right. Almost to negative 6. And we can plug this in. The second equation, 8x minus 5 times negative 88 over 17 equals 40. So 8x plus 5 times 88. So 440 over 17 equals 40. So 8x equals, we'll do 40 minus 440 divided by 17. So 240 over 17. So x will equal 240 over 17 divided by 8. So 30 over 17, or roughly, if we do that as a decimal, 1.76. Okay, that looks about right. So our ordered pair there, and that should be negative, right? So we did 40 minus that. Let me make sure I did that right. Oh no, that should be positive. let's see, 8x minus 5 times the y value equals 40. X plus oh yeah, that should be positive. Sorry, that makes sense that that's positive. That's our x value. So over here, that makes sense. So 30 over 17, comma, and then we've got negative 88 over 17. Okay, and there's our point of intersection. All right, and that's all for now. Sorry, that was a longer video, but hopefully you fast forward through the stuff you didn't need to see.